Hello everyone, this is Dr. K. Evangeline Supriya working as an associate professor in the Department of Humanities and Science, SRIT Engineering College, Anantapur, Andhra Pradesh. Welcome to the Engineering Physics Lab. Today we are going to perform the dark room experiments. Today we are here to perform the Newton rings experiment. The aim of the experiment is to determine the radius of the curvature of the given plano convex lens by forming the Newton rings. So the principle involved in the Newton rings experiment is interference. What exactly the interference is? Change in intensity at the point of superposition is nothing but interference. Now look at the operators. This is the sodium vapor lamp, which is a monochromatic source having the same constant phase and amplitude and wavelength, and this is the traveling microscope. Here is the telescope. As you can see the arrangement, this is a wood arrangement which is a plain glass plate inclined at an angle of 45 degrees, and these are the two, one is glass plate and one is convex lens. So one is glass plate and another one is convex lens. So convex lens means it is having the one side it is having the curved surface and one side it is having the flat surface. Now we are going to place the curved surface of the plano convex lens on the plain glass plate, which is inclined, which is placed here at the bottom of the telescope on the carbon paper on in the wood arrangement. So this is the setup we are going to have to perform for the formation of the Newton rings. Now this is the telescope. This entire apparatus is called the traveling microscope, and this is called the telescope. These are the keys to adjust, to move the telescope and to adjust the traveling microscope. Now it has two scales, one is vertical scale and the horizontal scale, but we are here using only the horizontal scale because the lens we have kept here are completely horizontal, so we are looking after only the horizontal scale. Here it is also having the vernier scale. As you can see this, there are the total number of vernier scale divisions is 50 divisions are there. So the number of vernier scale divisions are 50. As you can see this in the main scale division, it is having from 0 to 1, 1 to 2, up to it will goes on up to 22. So the value of one main scale division is 0.05 centimeters. So in order to find out the least count of the given traveling microscope, as you can see this, the formula here we are having the value of one main scale division by total number of vernier scale divisions. As I earlier said, the value of one main scale division is 0.05 centimeters. Total number of vernier scale divisions is 50 divisions. Now coming to the least count, we have to substitute the above values in the formula. We will get the least count is 0.001 centimeters. The wavelength of the given sodium vapor lamp is 5893 Armstrongs. When it comes to the centimeters, it is having the 5893 into 10 to the power of minus 8 centimeters. Already we have known that the refractive index of the air mu is equals to 1. Now we can see here when a monochromatic light source is incident on the glass plate which is inclined at an angle of 45 degrees, the light will reflect on the air film which is formed between the plano convex lens and the glass plate. Now the light will reflect from the upper surface and lower surface of the air film and will superimpose and forms the interference pattern having the alternative dark and bright fringes arrangement. These rings are called the Newton rings because it was first observed by scientist Newton. As you can see there in the board, we have the formation of the interferogram. The most central ring is the dark ring. That is why we are considering here the dark rings. You can see in the traveling microscope here in the kit, we are seeing the formation of Newton rings. So place the crosswire. Now we have to place the crosswire on the 10th ring, so that we have to move the traveling microscope from 10th ring. So when I coincidence the crosswire on the 10th ring, we have to read the vernier scale division and the main scale division. Again, by using this screw, we have to move the crosswire to 6th ring. 10th, 8th, 6th, 4, 2 and then 0. That we have completed the right side. And again we have to coincidence the two second ring on the right side. Likewise we have to move the telescope and we have to move the rings. As you can see this on the left side, I have coincidence on the 10th ring. From 10th it will come to 8th and 8th to 6th, 6th to 4th, 4th to 2nd. Again we have to coincidence with the 0, that is the dark ring, centermost dark ring, and again we have to move on the right side, that is second ring, 4th ring, 8th ring, 6th ring and 10th consecutive ring. Likewise we have to determine we have to read the readings of both vernier scale and main scale for the Newton rings, and we will get the diameter of the mth ring and diameter of the nth ring. Now where Dn is the highest ring, Dm is the lower ring. Now we have to place the values here. Capital R is equals to dn square minus dm square by 4 lambda into n minus m. After calculating all the values, we will get the value of radius of the curvature of the given plano convex lens by using Newton rings, by doing all the arrangement along with the sodium vapor lamp, plano convex lens and glass plate and telescope and traveling microscope. The principle involved in the formation of Newton rings is interference. Change in intensity at the point of superposition is nothing but interference. This is how the formation of the Newton rings will be formed by using the principle of interference. Thank you.